In this video, we are going to discuss about the difference between the hardware control unit and the microprogram control unit. So, if we see the speed, the hardware control unit is high speed compared to low, and if you go to the hardware complexity, it is higher, and it is for microprogram control unit is very low. And the control memory here it is not used here, but here we are using RAM and ROM to store the data signals. And the control signal used is nothing but the combination circuits like encoder and decoder are used. So here it is nothing but a microprogram are used generate this control signal. Since a micro program is used, if you see the flexibility here is low because we don't have memory and we can't able to uh, make a immediate change. Whereas in micro program, the control unit, since it is a program, we can change the control signal easy. So the flexibility is higher. Next, uses. It is used in the RISC CPU. So what does RISC means? Reduce instruction set computer. Whereas this is used in CISC. It is called as complex instruction set computer. Now let us discuss about the control units. Control unit is nothing but a brain of brain of the CPU. Okay, so it will control and coordinate all the activities. Right? Control and coordinate all the activities. So it is present inside the CPU, which is along with the ALU registers, right? Registers, clock signal, memory, right? So what is the function of the control unit is uh, it will tell the instruction register to load the instruction. It will tell the program counter to implement. It will also tell the ALU whether to add, subtract, or to perform the logical instructions, or it will tell the memory whether to read or write, and it will tell the mux which part to select. Right, which we have already discussed in the data path, right? So it is like a traffic controller, right? So it will tell which direction the vehicle must go, which or when to go. All right. So why we need a control unit is because without it, the CPU component, that is the ALU, memory, and register, don't know which data to operate on and which operation to perform and when to transfer the data. Okay. So this is the operation of the control unit. Okay. So there are two types of control unit. One is a hardware control unit, and another one is microprogram control unit. We have discussed already, right? So whenever if I use MIPS or ARM operation, it is processor. It is called as hardwired CPU control unit. Suppose if I use a Intel x86 means it is a microprogrammed control unit. So this is an example of control. So what does this MIPS represent means? This is nothing but a microprocessor without interlock pipeline stage. So if I use a pipeline, it will be very efficient, right? So the microprocessor is nothing but a CPU, and without interlock on the pipeline stages, so you know the 5 stages, right? It start from instruction fetch, instruction decode, execute, memory access, and write back stages. So what is without interlock is here we are not using the pipeline registers, right? So and here we are not using that uh, stall, that pipeline stall or not. So that it will be of uh, it will be faster, so that it will be faster, and it is used in the BS instruction set computers. There is another technique called interlocked pipeline stages. As this MIPS was found in the year 1980 at Stanford University. Okay, so now mostly we are using this microprogrammed control unit. In the without interlock pipeline stage, we are using reordering. That is, the compiler with rearrange the instruction in order to avoid the data hazards, and it will perform no operation, NOP operation if it is needed. Whereas in the interlocked pipeline stages, it is a hardware mechanism that will automatically pass the pipeline whenever the later instruction will depends on the result on the earlier one. Okay, so in the interlock pipeline stages, we are using we will insert a stall. That is a major difference between the interlock pipeline stages and without interlock pipeline stages.